Good morning. This is your stats sensei, Mr. Spensei, and we're going to do an exit ticket and we're going to briefly do the calculations for the hypothesis test and confidence interval for a paired data distribution. So sociologist was investigating the ages of grandparents of high school students. The sociologist collected data on the current ages and years of the students' maternal grandparents by taking a random sample of 10 high school students out of 1163. So we have a sample size of 10. That's important. The differences in ages follow a normal distribution. That's also important because our sample size is small, so they needed to tell us that it was normal. So enter the data into L1 and L2 and then L3. Well, we didn't have any data to enter L1 and L2, into L3, but we do in L1 too. So it says complete the table and test the differences at alpha equal 0.05 to determine if the grandmother is younger than the grandfather. So we're going to basically go grandmother's age minus grandfather's age, and we'll need to look at that in a moment for our hypothesis, but let's go ahead and get our data entered. So we go to stat and then arrow over to, and we have edit and we highlight. We put the data in grandmother's age in L1, grandfather's age in L2, but we need to get the difference. To get the difference, we're going to go second 1 minus second 2. And there we have our list of differences. So let's go ahead and record those down. So we have a 1, a -5, a -10, an 8, a -5, a -8, a -2, a 0, a 4, and a 4. If we have positive numbers, the grandmother was older. If we have negative numbers, the grandfather was older. All right. So our hypothesis is HO. The null hypothesis is always easy. Mu D equals 0. But now we need to deal with grandmother's age versus grandfather. So we're going to have grandmother. I'm going to write her off here. Grandmother. And and father. You know what? I'm just going to write mother and father. Mother, father. And I'm going to pick an age for the mother. Let's just say we pick 70. All right. Well, we want to see if the grandmother is younger than the grandfather, so I need a larger age for the grandfather. So that's going to be a less than. Just put in random number for the mother and then make sure that you follow the prompt for the father. So the father needed to be older. So that tells me the direction I need. So I need a mu D less than 0. Our formula, T equals, it's basically the same as what we had before. So I'll start off writing it that way, but then I need to come back and I need to drop some D's on it. All right, so there we go. Well, the population mean is easy because the population mean is 0. The sample size we know is 10. We just said that it was going to be a less than, so it's going to be this direction. I need to draw a picture of it. This is centered at 0. All right, but I can't finish drawing the picture until I have XD and SD or XD. So let's go ahead and calculate that. So stat calc one variable statistics. And the list I'm interested in is not in L1, nor is it in L2. It's actually the list I have now in L3. So second 3. And I get a negative 1.3. And I get a standard deviation of 5.755. Make sure you choose the one with the S because we calculated that using sample data. So this right here is negative 1.3. That's my mean. We have a less than. And this is my X bar. All right. So we're going to plug into our formula. Well, our alternative is that it's less. So probability that T is less than negative 1.3 minus 0 over SD of 5.7551, 5.7551 divided by the square root of 10. Now we're going to go run our test. To run our test, we're going to go to stat test. We just need t-test, and since this is a special case of the one sample, we just go to one sample. We have data, not statistics, so data needs to be highlighted. Our mean is 0. Our list is not L1, it's L3, so second 3. And we need to have the less than selected on the calculator. And we end up getting the probability that t is less than negative 0.7143, gives us a p-value of 0.2465. So in this case, we have a pretty large p-value, especially when we compare it to the alpha. So 2,465 is greater than 500. So our decision is we're going to fail to reject. So grandmother's age is not less than grandfather. That would be basically what we would conclude. Also says construct a 97% confidence interval. So our formula, X bar plus or minus T star S divided by the square root of N. Only thing is we need D's right here. Well, we already know the N is 10. Our X bar D we had from previous of 5.7551. Or excuse me, that negative 1.3, excuse me. X bar D is negative 1.3. Our sample standard deviation is 5.7551. We need to calculate our T star, so we're going to go to inverse T. It's going to ask us for our area. Our area is going to be 1 minus 0.99. 1 to 97%, so 1 minus 0.97 divided by 2. Degrees of freedom is going to be 10 minus 1. So let's go ahead and do that. Second vars, inverse T, parenthesis 1 minus 0.97, close parenthesis, divided by 2, 10 minus 1. And I end up getting 2.5738. So 2.5738. Now that I have that, I can plug in, and negative 1.3 plus or minus 2.5738, 5.7551, the sample standard deviation, divided by the square root of our sample size of 10. We're going to need to run the interval now. We'll go stat test, T interval, which happens to be number 8. Data needs to be highlighted, L3, because that's where our data is. And our confidence level is 0.97. And we end up getting negative 5.984. To 3.3842. Now, if we notice, 0 is contained in the interval and 0 is no difference. So at 97%, we cannot say that there's a difference in ages. We can't say that one's older than the other. Although we have some evidence, there's not enough to say that there is a difference. It's not statistically significant. All right. Appreciate you watching. Hope to see you on the next one. Thank you.